grade 10, so what we're going to do today is we're going to prove some identity. Let's just make it maths, right, and go for it. Okay, so in proving identities, what we need ready on hand is a bit of a sense of humor, and to remember that tan theta equals sine theta over cos theta. So yes, pop that down. And the other one that we know, right, is that sine squared theta plus cos squared theta equals 1, right? Two identities that we know. And do you remember, or, at least have you looked up and remembered, okay, well, this one, the second one, we can manipulate into two other forms. Remember that, right? So if we subtracted, let's say, cos squared theta from each side, then we'd have sine squared, that's a terrible, theta equals 1 minus cos squared theta. And also, let's rock out a different color and go, well, if we subtracted sine squared, we'd have cos squared theta equals 1 minus sine squared theta. Okay, so we got that for reference if we need it. Now, it kind of goes maybe slightly without saying that clearly if we squared the left-hand side, we could square the right-hand side, right? So tan squared theta is sine squared theta over cos squared theta. Okay, so we've got those in the bag. Jot them down at the top of the page. As soon as you turn the page, I find it useful. You just got them there for reference, so you're not just pulling them from your head. Okay, so in proving identities, we've got this left-hand side here, and we need to prove that it equals the right-hand side over there. Now, we're not treating this as an equation. So you're not going, okay, well, you've got the left-hand side, and maybe we're going to add something to each side of the equation. We need to take the left-hand side and manipulate it until it looks like the right-hand side, or vice versa, right-hand side until it looks like the left, or manipulate them both until they look the same. So for this one, I'm just going to kind of guide us through the process and say, well, the left-hand side I'm going to choose to do, and tan squared theta, well, I know I can write that as sine squared theta over cos squared theta, and sine squared theta is just sine squared theta. Okay, so that's the left-hand side. I'm going to draw a little line here in case, I don't know, maybe we're going to get stuck at a point, and then we'll change the right-hand side and the two might look the same. But for now, we've got that. Now we've got two fractions, and it would be nice if we wrote it as one fraction with a common denominator. So this is going to be sine squared theta. What's the second term in the numerator going to be? Well, we've got the sine squared theta, and we need to multiply it by cos squared theta. Okay, the numerator can certainly be factorized. And what's our highest common factor in the numerator? Well, I see sine squared theta common to both, so sine squared theta, 1 minus cos squared theta over there. Okay, so things are looking good. Let's keep drawing our line down there. And so we can go along and go, well, let's just pause for a second and go, whoa, this part here, 1 minus cos squared theta, this over here, doesn't it look like one of the things we wrote down? We could write this as sine squared theta. Okay, and if it will probably help us if we can see where are we trying to get to. Well, we're trying to get to tan squared theta, sine squared theta. Well, tan squared theta is staring at us in the face because there it is. Sine squared theta over cos squared theta is just tan squared theta. And didn't we just say that 1 minus cos squared theta is just sine squared theta? Well, isn't that the right-hand side? So, great stuff. We can go, well, equals the right-hand side. Oh, and then what's an entirely compulsory activity for you is to write down a smiley face because we're so happy that we've proven that identity. Okay, no, tongue-in-cheek, of course, but we definitely finish up by going, yes, it equals the right-hand side. And I'm going to have a little smile to go, yeah, I'm chuffed that I got that one. So that's our process. Now we've got lots of these to practice through. I've already copy-pasted our identities here, so they're ready to go for this next one. Now, so for this next one, we've got a left-hand side and a right-hand side. Now, let's make it yellow, so there's nothing showing which way we're going to go. We need to choose either the left-hand side or the right-hand side and then manipulate it. Which side do you think I'm going to choose and why? Well, I'm going to go for the left-hand side without question because the left-hand side looks a whole lot more complicated. So it looks like I'll be able to work and manipulate it and make it simpler to make it look like the right-hand side. There's squares going on and stuff, so it feels like there's more that we can work with here. So let's go for it. Let's take our denominator to start with. So we've got our denominator. Looks like it wants to be factorized. How could we factorize the denominator? Well, looks like a difference of two squares, doesn't it? So it looks like we've got cos x plus sine x, cos x minus sine x. Now, wait a second. This bit here looks remarkably like this bit over here. So it feels like we're getting quite close to solving. In other words, this part over here, this first bracket, and where does it feel like maybe we're starting to go? Because it does help if we have a bit of a feeling building up as we go along here. Well, I don't know. I mean, I ask you, and this is the second one you're doing ever, and this is not the second one I'm doing ever, and I'm still developing a feel here, but my feel that I'm sensing is this is probably going to cancel with something in the numerator. And then you'll just be left with this in the denominator. And there'll probably be a bracket up here that goes cos x plus sine x. Kind of feels like that, right? If those two cancel and you're left with that, then you're left with the right-hand side. Well, maybe it doesn't feel like that just yet, but that's kind of the feeling that we're developing here. So the numerator, I don't want to write it down just yet, because if I write it down, it's going to look the same, and then what? So this would be nice if we could factorize it, because if we could turn it into one term, then we'd have one term over one term and we could cancel. So I'm just going to, in a little scribble down here, remember something like, can you imagine you had x squared plus x over x plus 1? And you're like, well, we can't cancel anything there because what we want is one term over one term. So you would have common factor, x plus 1, denominator, pop it in brackets to make sure, that cancels out quite nicely. So that's kind of our idea here, but we're using that idea of, well, one term over one term means that we can start cancelling. And this is multiple terms. Now, I wonder, what can we do to that numerator? Do you have any ideas? Look at these things on the right-hand side, these identities, so that we could manipulate it and factorize it. There's only really one option here, because there's no tan theta and sine theta, cos theta. Sine squared theta plus cos squared theta equals 1. Well, hang on a second, there's a 1. So why don't we write that one as sine squared theta plus cos squared theta. Right? That's the same as 1, isn't it? That green part's that green part. And I'm going to write the remaining bit, this 2 sine x cos x. And yes, there's a reason I'm writing it in this order, because now what should hopefully start coming clear is we can factorize that numerator. I'm going to see if I can leave that in picture, because it's nice if we can see where we can go. So this first bracket, I'm going to write the denominator is already one term. So cos x plus sine x, and our second one is cos x minus sine x. We are already expecting one of our brackets to be cos x plus sine x, so it cancels, because we know where we're trying to get to. So let's see if we can factorize the numerator, and let's go for here. And I tell you that it's a trinomial that can be factorized fairly easily. Well, if we've got, here we've got, well, cos x times cos x would give us this cos squared x. right? And sine x times sine x would give us the sine squared x that we got here. Did I switch between thetas and x's? Doesn't really matter what, as long as we're consistent. So these should all be x's. So cos x times cos x, well, let me just write it in, plus and plus. Just pause and make sense of that factorization. I'm just overthinking it here. Okay, you can test for yourself that times that times that times that times that does give us that bit at the top. Okay, so as we kind of were expecting, this whole bracket cancels out, and we left with cos x plus sine x, cos x minus sine x. In other words, what we're left with is just the right hand side because we've cancelled those. Okay, now, as I said, we're developing a feel for these, and we also know where we're going. So let's use that to our advantage. So let's see, we've got 1 or 2 more here. We've got actually 3 more. So I think let's hit 1 more in this video and then maybe have a bit of a pause so you can hit the next one in the next video. So prove tan squared x plus 1 over blah, 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 sine squared. So again, question of course would be, do you want to change the left-hand side or the right-hand side? I'm going to choose the left-hand side. Why do you think I want to work with the left-hand side here? Well, the left-hand side's got tan x's in it. So I know that we can use sine x over cos x. So we're going to have tan squared x is going to be sine x over cos x, or sine squared x over cos squared x. And this tan squared x is also going to be sine squared x over cos squared x. Now you're going to have one of these multi-level fractions before you know it, right? So we're going to have our fraction line, that's that big one over there. And this over here, let's just let's do this. I just want to make it clear what we're working with here. This blue part we're going to put on top. So let's do that and say, well, that's going to be sine squared x over cos squared x. And in the denominator, let's go for a nice yellow. Come on, work with me. And we've got that over there is 1 plus sine squared x over cos squared x. Whew. Hopefully that was all worth it with all the colors. Maybe not. Okay, so for here, I mean, I think we've manipulated something like this before. I seem to remember one that was similar. In the back of our minds, we know that what we're trying to get to is, what is it? Sine squared x. Let's just keep that in the back of our minds. So we've got this is equal to our nice big fraction. Not too much we can do on the numerator just yet, cos squared x. Denominator, however, it's going to make sense to make this over cos squared x. And therefore, this is going to be sine squared x. What's the first term in the numerator of this yellow fraction going to be? Well, we've got this cos squared x over here, plus the sine squared x. Because cos squared over cos squared is 1, sine squared over cos squared is that, which is tan. Okay, now I do remember us doing one similar to this, because what some of you managed to see, which was very impressive, was to go, well, that cos squared and that cos squared, don't they just cancel each other out? And cos squared x plus sine squared x is just 1. So therefore you got sine squared x over 1, which is sine squared x, which is our right-hand side. If, however, you perhaps wanted one step in between, also kind of makes sense that you might have rather written this as sine squared x over cos squared x. If you're dividing, you could use that old school divide sign. But why don't we tip and times at the same time? So if we divided by this yellow fraction, we could times by its reciprocal, which is cos squared x over, well, cos squared x plus sine squared x is 1. And then we could see why these two cancel so nicely. Okay, so pause, breath, take it in. Good stuff. Let's rock on with another example, and let's just bomb through. Let's go through. I don't know. Otherwise, we have to stop and start again. Let's go. Okay, feeling the rhythm. You're feeling. Come on, you still got that energy. I shouldn't ask those questions, should I? Okay, so here we go. Left-hand side, right-hand side. Okay, which side do you want to manipulate? The left-hand side or the right-hand side? And tell me why, because it doesn't jump out to me which one immediately, but which one do you think you want to work with? Okay, well, I want to see which one you said and change my mind, and I'll see you in the next video, because I actually want to, well, I was going to say I want to read what you wrote, and that would be great, but I'm not going to have a chance because I'm going to make the next video. So, you know what, let's get back to our music and